हरि करना।
So let's move ahead and let's see some of the new terminology that we'll be using in our data science modeling from now onwards. That is selection bias. So selection bias refers to the practice of selectively choosing data. This is our side. Consciously or unconsciously in a way that leads to a conclusion that is misleading or ephemeral. So selection bias refers to the practice of selectively choosing data. Selection bias is different, sample bias is different again. Okay. Selection bias refers to the practice of selectively choosing data consciously or unconsciously in a way that leads to a conclusion that is misleading or ephemeral. So, if you specify a hypothesis and conduct a well designed experiment to test it, you can have high confidence in the conclusion. This is frequently not what occurs. However, often one looks at available data and tries to discern patterns. But are the patterns real, or are they just the product of data snooping? So, which is nothing but the extensive hunting through the data until something interesting emerges. That's what we call as a data snooping. Snooping. So it's nothing but extensive hunting through data in search of something interesting. And once you get it, you will say this is what data is trying to convey to us. But that may not be the fact. So those patterns may be real, or are they just the product of data snooping, that is extensive hunting through the data until something interesting emerges? There is a saying among the statisticians: if you torture the data long enough, sooner or later it will confess. Really, that's what we do now as a data scientist. Okay. It's a saying among statisticians: if you torture the data long enough, sooner or later it will confess. So that's what by and large we call it as a data snooping. The difference between a phenomenon that you verify when you test a hypothesis using an experiment, and a phenomenon that you discover by perusing available data, can be illuminated with the following thought experiment. So, and we have vast search effect. So, vast search effect bias or non-reproducibility resulting from repeated data modeling or modeling data with a large number of predictor variables. Let's look into that, but let's take an example before that. So let me say this as selection bias. Selection bias. So let's take one example. Imagine that someone tells you someone tells you they can flip a coin and have it land flip a coin and have it lands have it land heads on the next 10 tosses. Next 10 tosses. You challenge them, and you challenge them nothing but you have asked him to do that 10 times. Let him flip a coin 10 times and let's see what's going to happen. So then he has proceeded, then they proceeded to toss the coin 10 times with all flipping, with all flips landing heads. So after the experiment, all flips, all flips landing heads. So with this, clearly you ascribe some special talent to this person. So the probability that 10 coin tosses will land heads just by chance is 1 in 1000. Now, imagine that the second challenge. Imagine that the announcer at a sports stadium asks the 20,000 people in attendance each to toss a coin 10 times. So we have 20,000 people to toss a coin, uh, will will toss a coin 10 times. 10 times, and they have to report, and to report to an usher if they get 10 heads in a row. That's it. This is the second one, second task. So the chance that somebody in stadium will get 10 heads is extremely high, more than 99 percentage minus 1. It's 1 minus the probability that nobody gets 10 heads. So clearly the chance would be very high in this case. So selecting after the fact that the person or persons who gets 10 heads at the stadium does not indicate they have any special talent. It's more likely luck. So since repeated review of large data sets is a key value proposition in data science, selection bias is something to worry about. So that's the reason. So as a data scientist, knowing these three terms are very, very important to us. So we all know that our value proposition. So repeated review of large data set is a key value proposition in data science. So selection bias is something to worry very much about. So a form of selection bias of a particular concern to data scientists is what John Elder calls that as a vast search effect. Let me show you that now. Vast search effect. The name itself is saying vast search effect. Uh, if you repeatedly run different models and ask different questions with a large data set, you are bound to find something interesting. But is the result you found truly something interesting, or is it the chance of outlier? That's what is called vast search effect. So we can guard against this by using a holdout set, and sometimes more than one holdout set against which to validate performance. Elder also advocates the use of what he calls the target shuffling. Target shuffling to test the validity of predictive associations that a data mining model suggests. So, typical forms of selection bias in statistics, in addition to the vast search effect, include non random sampling, cherry picking the data, so selection of time intervals that accentuate a particular statistical effect, and stopping an experiment when the results look interesting.